format. So you got to move stuff to one side. I guess I'd move left. So your f of x is natural log of x plus x minus 5, like that. Is that clear? Moving stuff left. Okay.
Yeah.
And then your derivative is 1 over x plus 1. Derivative of a constant minus 5 is 0. Now, so we need all this because we're going to evaluate here. Now, this is where I think we ran into problems last time is you really want to do all of this like in one step, meaning you want to let the calculator do all of this stuff. So I'm going to try and do it in a way here where if you enter this into the calculator with the parentheses around the numerator slash parentheses, you're going to be able to get the full answer there. So I'm gonna clear all. All right, so 8. You know, if you use like a Desmos Scientific, you don't have to quite do all the stuff with this. But if you got like a handheld TI-83, you got to make sure that you put parentheses around it because calculator doesn't know that you meant something else. So when you do this, you end up getting 3.484940852, like that.
Okay. And
you want to go out a bunch of decimal places. Now, this is like to round your answer to, wow, 6. Ooh. So yeah, you need all of these. You definitely need all of these. And then to do x2 is x1 minus f of x1 over f prime of x1. So notice that x0, 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 x1, 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 f of x on top, f prime of x on the bottom. So you're taking this number and you're putting it in for x1, which that's where this gets complicated because it's like instead of the 8 and the 8 you're putting this in. Okay, so what I mean by that, and I'll try to, it's gonna need a lot more room here. So it's this number minus natural log of this number plus this number minus 5 all over 1 over this number plus 1.
That's a lot.
So the way to do it in your calculator is to actually store this to X. There's an STO button to X, and then you just put X here. I can show you that if you want, but you're probably not going to get this one. You're probably going to get the previous one in your test. It's a little more doable.
Yeah.
Anyway, in terms of your answer here, X minus, let me get the natural log of X plus X minus 5 over 1 over X plus 1, like that. It ends up being, let me see if I can snip all this in. Let's actually snip them both in so you can see there. All right, so it ends up being, this is the second answer. So the 6 decimal place, 3.692104 would be my best guess on that.
Okay.
They do get easier from here. You know, that was a fairly challenging problem. Let me know when we can move on to 13.
Yeah, go ahead.
All right. 13 is a pure calculator problem. That's not right. Snipping tool. So you're finding the intersection of these two graphs. So you would graph this in y1 and this in y2. And of course, having the Desmos calculator is significantly easier to do this. But it's essentially the same. So cosine x, and it does say from 0 to 2 pi. Let me see here. What does it say? It does not. Okay, that's good. Sometimes they give you some restrictions on this. Now, if you get the graph of this, there's just one place where they intersect right there, and they just want the x value. What does it want here? 2 decimal places, so 0.11. You're just finding the intersection. So that's on your calculator, TI-8384, it's the second calc intersect. And you end up having to do this left or first curve, second curve. Have you seen that before?
Yes.
Okay. And there's only one, so there's not a, but so there's other problems where there could be like two, like if you can imagine the graph being more, or the line being more, like flat, there's potential for more intersections,
Yeah.
but we don't have any of those at this time.
Do I put it into the calculator?
What do you mean by that?
Oh, never mind. I'm sorry.
This is the answer. I mean, that the intersection point is right there. That's the line.
Yeah, sorry. I was getting confused. Okay. I'm ready for 14.
$14. Because you don't have to show any work, we're just going to do this with the calculator again.
Okay.
So what they're asking you here is to determine if there's a root between 1 and 2. And there is a proper way to do this, but what you're going to do instead is just graph it and see if it intersects the x-axis between 1 and 2. So the key there is to make sure it intersects between 1 and 2.
Okay.
And because if it doesn't, I mean, that's the problem here. So let me grab the snip of this. So you can see here. You can see here, yeah, it does. It's right there. Now, 5 decimal places, that's where the Desmos is kind of limiting here. So that means we probably do have to do it with the real calculator. I think it'll give you that. So let me pull up my TI-83. I've got an emulator here.
Okay.
That way you can see how to do it here. Tools. Right. Let me share that. All right. So if you ever need me something to show you something on the calculator, I can use this little emulator thing here. So we're going to graph the original function here, x cubed plus x minus 4. And then if you graph it, which isn't necessarily the best thing, you can say, okay, there's a graph. So you have to do the second calc intersect, or I'm sorry, 0, not intersect. 0 because you're figuring out where it crosses the x-axis. The left bound means left of it. It doesn't have to be really that close. That's left of it, right of it, somewhere right of it. And that's somewhere right of it. I know it's above, but think of it as being right of it. And then you always guess where it is. And then you can see here, the TI actually gives you, the more decimal place in the Desmos. So let me snip that in. You can see that there. So there's limitations with every tool you use, which you know from working. Sometimes you can't not everything does this. So it's 8, 7. So it'd be 8, 7, 5 decimal places, 8, 7, 9, but the 9 rounds up, so it's 8, 8, 0, like that, the 5 decimal places. Actually, the nice thing about it, since you've got a multiple choice, you can even just test your answers.
Yeah.
As you go.
Yep. Okay.
And so we're going to the next one.
Yeah.
All right. Okay, so now let me just skim through a few of these. Okay, yeah, so we're back to doing I don't know, we're kind of in that integral. We're doing integrals now, back to integrals. This
Yeah.
is 15. So there's generally a rewrite step in all of these to make them more appealing. And what that means is you're using kind of your exponent rules, your stuff you learn in college algebra, pre-calculus.
Mhm.
We're not doing the calculus set. So it's really the integral 7t to the 6th plus 1/5 times t dt. And for right now, there's one integral rule that you need to know, and it's called the power rule. It's kind of the same as the derivative power rule. It's the integral of x to the n dx. So you add 1 to the exponent and divide by the new exponent plus c. So this constant, hopefully you remember that. You said you've been through the course and it's in some capacity before. So so we got and forget about the constant. The constant just comes with, so you're adding 1 to the exponent and you're dividing by the new exponent. You're adding 1 to the exponent and dividing by the new exponent.
Okay.
So this, like for now, it's good to show it as +1, +1, +1. Eventually you'll just add 1. You won't think twice about this, but for now it's good to do 7t to the 7th over 7 t squared over 2 plus c. And so that's t to the 7th plus 1/10 t squared plus c, like that.
This isn't the one where you have to find C, right?
Not in this problem, no, but those are coming up. I mean, I'm guessing they're part of this assignment. But make sure you put that plus c in.
And it's capitalized.
Yeah, it might take lowercase, but typically it's capitalized. So all right. Let's see here. So next question. Another antiderivative. Grab the snipping tool. So this is 16.
Yes. Sorry.
Okay. So 16. Again, most general antiderivative, all that means is plus c. Your answer's gonna have a plus c in it. So just like the previous problem, it's really like 3 problems in one. So it's this 5x to the 9th minus 5x and the plus 4. So the antiderivative, again, you're going to add 1 and divide by the new exponent. It's really x to the 1. So it's minus 5x, 1 plus 1, divide by the new exponent. Now the 4, you might be, well, there's no x. Well, there is. It's really 4x to the 0. So you don't want to write this, but you're adding 1 and dividing by 1. So you want to remember, for a constant, the integral of a constant, it becomes kx. Like if it's integral 4, it's 4x. If it's integral 3, it's 3x, 1/2 x, things like that, plus c. Now, I believe they want you to simplify here. So just that's part of doing this. You'll get faster at it the more you do these. It might take the originals, I'm not sure. 1/2 x to the 10 minus 5 over 2 x squared plus 4x plus c. So 15 and 16 are for sure questions you want to kind of look at again, or maybe do ones like them, if
Mhm.
there is that option on the homework or something, because you really, these are like the basic ones you got to know how to do without question.
Okay.
All right, number 17. Look at that next. So I am ignoring this whole part where it says to check your answer by differentiation. What that means though is you can take your answer and take the derivative of it, and you should get back to the original.
Okay.
All right, so for this one, again, same thing. You're going to add 1 to the exponent, and that's where a lot of students try. They're like, oh man, there's my fractions. That's where you just go to your calculator. Just your calculator, do the math, enter thing, where it gives you the fraction. That's the shortcut for that. You divide by the new exponent, plus c. So you can you tell me the answer? If you're not sure, do you mind just putting that part into the calculator?
Yeah.
Really important that you can get the fraction here when you're doing this.
Oops. Would it be x to the 5/6 over 5/6 plus c?
That's the next part of this is when you have a fraction on the bottom, I'm going to
Mhm.
write the answer, it becomes the reciprocal. So that this fraction flips to come up here.
Okay.
And that's kind of a big deal. It's kind of a big deal to be able to flip it and then get that in front, because at some point we'll have some numbers in front that we'll have to multiply by, but really good job on that. That is the final answer on that one.
So always with the fractions with that one, you flip them.
Yeah, I mean, Pearson will take it on the bottom, but when you have your exam multiple choice, it's going to be this way.
Okay.
Let me know when we can move to 18.
Yeah, we can.
Okay. So 18 here. Ooh, again, rewrite is critical here. You have to remember that the square root of x is really x to the 1/2 power. You're not sure why. There's really a 1 there and a 2 there. What's called the index. The index is, the index is 2. There's a 1 there that's not written. That's why it's 1/2. So what does that mean? It means it's the integral of 5 over x to the 1/2 plus 5x to the 1/2. And what you really want is these variables in the numerator. So it's 5x to the minus 1/2 plus 5x to the 1/2. Again, we still have not taken an integral. We're still no calculus has been done yet. You're just putting it in a different format.
And then you do 5x to the negative 1/2 plus 1 over negative 1/2 plus 1, right?
Yeah. That's where at some point you want to get to the point where you can quickly add 1. 1/2 plus 1 is 3/2. it can get overwhelming to not have, you can start having like adding inside fractions, just maybe you can do the calculation as you go.
Um,
Question?
yeah, I'm sorry, I'm thinking. So you can't cancel anything out within that, or
Not yet. We do have to, we're gonna multiply the, this 1/2 really becomes 2/1 times 5. And you
okay.
can see it becomes 10, it becomes 10x to the 1/2. And then the 3/2 becomes 2/3 times the 5. So it becomes 10/3 x to the 3/2 plus c. But 19 is very similar. These are good to do. Like you gotta be able to do all of these with the just the numerical exponents. So again, there's this rewrite step before you do any calculus. The integral of 12y cubed, that's fine because the variable is already in the top. But this y to the 1/5, when you bring it up, it's negated, -1/5, like that. So this is actually, oops, sorry, not plus c. This would be a good one for you to try to work out here. If you
Okay.
don't mind. Just same thing we've been doing, and you can go as far as you want. But I give that a try, please.
Okay. I got 12y to the 4 minus 5y to the 4/5 over 4/5. Yeah.
Okay. This one's over 4. I didn't quite hear that. Plus c.
Yeah.
That's
Yeah.
important. Okay. Keep going here. You got to simplify a little bit here. You'll definitely
Would this still be a reciprocal problem?
only the fractions are reciprocal. That's you just divide, straight divide. Like 12 divided by 4.
Yeah.
That's normal division. Over here, it's flip of this times the number.
So would it be 3y to the 4th minus 5? Sorry. 5y 5/4 to the 4/5. Hold on.
Because at some point you got to multiply the 5 and the 5/4.
Yeah. I don't know why I wrote it like that. I got 25 over 4y to the 4/5
Good. Let's see.
plus c, yeah.
Yep, good. All right. Good. Right. Number 20. Let's see. All right. So the at first glance, you might say, I have no idea how to do this. This is very different. The other ones, it is, and it's another rewrite though. So your rewrite is distributing in here. So we did this with derivatives. Maybe I don't remember exactly, but like when you don't know all the derivative rules, they give you some where you have to apply some algebra first or rewrite here. In this case, again, there's no calculus yet. You're just multiplying it. So 35x minus. Now it's 5x times x to the minus 5. Again, you got to just remember your exponent rules. So when the bases are the same and you're
Mhm.
multiplying, do you remember that exponent rule?
You just add,
You
you
add,
add the
yeah,
exponents,
yeah.
yeah,
So it becomes 5x to the minus 4, like that.
okay.
All right. So then now you're ready to do your calculus. So why don't you jump in here and see if you can tackle this part, please.
Okay. Would it be 35 over 2x to the x squared
Good.
plus 5 or negative 5 would be
Why
minus,
don't you fully simplify this, then give me your answer because
yes,
there's some sign things going on. Just we can work it out.
okay. 35 over 2x squared minus 5 over 3x to the negative 3 plus c.
Yes. Really good. Really good.
These make more sense than I remember them making.
It also looks like you may not have put 25 in. I don't know if that was intentional or not, but
20, oh. Maybe I didn't.
if you can, go ahead and drop in the chat or email it because I'm going to do 24 next because it's more in line with what we've been doing. And then we'll go
Okay.
back to the other ones. Sometimes I do things out of order to best help you.
Yeah.
All right. So the what's going on here is you're still integrating this thing, and you kind of asked me about it earlier. Like you're like, when do we have to find C? Well, when you're given what's called an initial value, an IVP, that's when
Mhm.
you have to find C. So go ahead and find the antiderivative of this for me, please.
Would it be 7/3 x to the third plus 5/2 x to the second minus 6x plus c?
It's very good. Very, very good. All right. Now, to find C, you have to use this X value. This means X is 0, F of 0 means X is 0, and then F of X or Y is 2. So you're putting those values in. It's 2 equals 7/3 0 cubed plus 5/2 0 squared minus 6 times 0 plus C. Okay, and what this means is these all go away because 0 any power 0 times 0 is 0, but it does not mean that C is always whatever the number is. Like that's a classic mistake to make, to think that C is that there. So your answer is your F of X is everything you just wrote, 7/3 x cubed plus 5/2 x squared minus 6x plus 2, like that.
Okay.
So I saw you got an email for 25. Let's take a look at this before we yeah, we'll do this one next because it's kind of again more in line with what we've been doing, and then we'll go back to the others. All right. So this time they're giving you the second derivative, which means you have to integrate twice. They give you two initial conditions. This is the first initial value problem, and then this is the second initial value problem. So basically, when you take the antiderivative, you always go up one level. You go up to the previous thing, which would be the first derivative. So basically, you got to take two antiderivatives of this. So first integrate 4 minus 24x dx, and this is 4x minus 12x squared when you're done with that. So that's your derivative. That's your y prime.
Mhm.
Actually, I guess I should use the right notation here. Y
I'm
prime.
just taking the derivative, or am I finding the
You're
antiderivative?
finding the antiderivative, antiderivative still. But we got to find C. So we do that with this first initial condition up here. So it says that 7 equals 4 times 0 minus 12 times 0 squared plus C. And so C equals 7. So you're going to rewrite this y prime of x equals 4x minus 12x squared plus 7, something like that. And now we got to do yet another antiderivative. You have to integrate this thing. So you integrate it once. So they're giving you the second derivative to start. You integrate it once to get the first derivative. You integrate it again to get the original function. All right. So would you find the antiderivative of this for us, please?
Yes. Would it be 2x squared minus 4x to the third plus 7x plus c?
That is correct. So you can always check by taking the derivative. Derivative that gets you back to the previous line. That looked great. And then that second initial condition says that 5 equals 2 times 0 squared minus 4 times 0 cubed plus 7 times 0 plus c. And again, it's a mistake to think that c is always that number. It has worked out into your problems. So maybe it will work out in your course, but you've heard, you know
Yeah.
what happens when you assume things. I hope you have heard that before.
Yes.
Okay. All right. Okay. So those are those are all kind of the nice antiderivatives. And then you get to 21, which is more difficult. The 21 is what's called it starts the u-substitution part of the course. Does that at all vaguely sound familiar to you?
A little, but I think at this part of the course, I was extremely confused at that point.
Okay, so like again, like you don't know the antiderivative of cosine of theta over 7. You just don't know it. But you know, if it were just cosine, you would know how to do that, but it's not.
Yeah.
Okay, and that's the issue. So your u substitution is where you substitute in for something in the problem. In this case, you substitute in for usually it's something in parentheses. It could be an exponent. It could be under a root. It could be in the denominator. Like there's a long list of things that it could be. And it's like you as the student have to like know or figure that out. The problem is you don't know until you've done a bunch of these. So, you need a lot of help when you do it for the first time. There's no like magic to figuring these out. So
Mhm.
you make a guess, you make your best guess. All right, I think it's that. Then you take the derivatives. So the derivative of, and this is really, if you need to rewrite it, you can. It's 1 over 7 d theta. And then you solve for this d theta. So your d theta, you multiply both sides by 7. So your d theta equals 7 du, like that. All
Okay.
right. So when you go back to your original problem, you always substitute in your u. So you're always going to substitute for whatever this is and for your d variable, your d theta. So the other stuff you don't substitute in for. So it's 9 cosine u. Instead of d theta, it's 7 du. And what is supposed to happen is it's supposed to be much nicer. Now, maybe it doesn't look like that at first glance, but these multiply. That's 63. You can bring it out of the integral. So it's 63 integral cosine u du. And this is better. This is way better. Like you're supposed to say, oh yeah, I know how to take the antiderivative of cosine,
Hmm.
or at least, that's the idea here. So the antiderivative of cosine is sine. You bring the 63 down, you still add the c, but then you have to back substitute in for u. So u was theta over 7, so that has to go back in. A lot of times students forget that, and in a multiple choice, you can be guaranteed that there'll be an answer there where it's not back substituted. So
Hmm.
this is your final answer here.
Okay.
Any questions, thoughts on that?
Um, for the most part, right now it makes sense, but I think like when I try to go do it on my own, I'm gonna like get lost.
Math's not a spectator thing. You really got to do some problems, see where you're at. But like that's why I do the lesson notes in the videos. Like you really do want to go in and rewatch, like a problem like this. This would be amazing not amazing. It'd be great to redo, on your own.
Yeah.
But so let's look at the next one here. 22. So we haven't really talked about this idea, but you can actually break this up into two different integrals. So it's integral e to the 7x dx plus integral 2e to the minus x dx. So that's kind of thing one. You can always kind of break them apart if you want. And it kind of makes sense here because it's kind of like two problems in one. You're just
Mhm.
going to uh you're going to do this one. So let's look at this e to the 7x first. And we're going to do this u substitution thing. So as I mentioned, your u could be like, for example, the exponent, which in this problem it is. So your du is 7 dx. And then you always solve for whatever the D variable is in your problem. So in this case, you solve for dx. Dx is du divided by 7. And then you put that back into the original function there. Is that okay, maybe?
Yeah, yeah.
All right, so let's see here. So that way this looks is integral e to the u, and then it's du over 7. So it becomes 1/7 integral e to the u du, like that. And so the antiderivative e to the u is e to the u. See, so you back substitute your u was 7x, so it's 1/7 e to the 7x plus c.
And that's only 1/2 of the equation, right?
Fortunately, that you're right. That is only 1/2 of the problem there. So you have to do the rest. Okay. So the rest here is 2e to the minus x. So integral 2e to the minus x dx. You can bring that 2 out if you want. So 2 integral e to the minus x dx. Your u is this minus x. So your du is -1 times dx. Solving for dx, it's du over -1, like that. Does that make
Yes.
some sense there?
Yeah.
Right. So that's 2 integral e to the u du, like that, over -1. So that negative can come out. So it's -2 integral e to the u. Again, it always goes back to something like really simple. That's the whole idea of these u-substitutions, something that's totally doable, can be done
Mm-hmm.
in a there. So so that becomes e to the u, -2 plus c, and then it's -2 e to the minus x plus c. There's your answer. But you might be thinking, well, there's 2 c's. Like, do they cancel? No, that like you eliminate one of them. You only have 1 c in your answer. So it's 1/7 e to the 7x minus 2 e to the minus x plus c.
Okay.
Any questions on that?
No.
Okay. So I don't have time to do another question. Maybe I'll talk through it. Let's see what it is. Yeah, so this one. Yeah.
Is it
So
similar to this past one?
yeah, I mean, it's more or less. I mean, then there's a million calculators out there. So if you're, if you're really hard pressed to finish this, you can
Yeah.
go out to the internet there and do that. But basically, I mean, I'll give you the answer. So it's 1/6 sine 6x plus cotangent x plus c. But it's basically just like we've been doing.
Okay.
All right, we're going to go ahead and stop here for today. Sorry, I didn't
Okay.
mean to do that. I meant to actually stop the recording.